Monohull. A monohull is the most common and classic hull configuration, consisting of a single continuous hull that serves as the vessel's whole buoyant body. Because a monohull relies solely on one hull for buoyancy and stability, it usually sits deeper in the water and uses ballast, keel structures, or hull shape to maintain balance, particularly in rough waves. This makes monohulls extremely predictable in handling and capable of effectively cutting through waves, which is why they are the preferred choice for commercial cargo ships, tankers, cruise liners, Navy vessels, and classic sailboats. However, the single hull layout results in higher drag and less stability at rest than multi-hulls. Despite this, their structural simplicity enables easier construction, straightforward maintenance, and great load-bearing capability, making them versatile across nearly every maritime sector. Catamaran. A catamaran uses two parallel hulls connected by a central deck or bridge structure. This twin-hull configuration significantly increases the vessel's footprint on the water, resulting in strong transverse stability with minimal side-to-side rolling. Catamarans often have shallower drafts because each narrow hull cuts through the water with a less wetted surface area than a monohull carrying a similar load, resulting in lower hydrodynamic drag and improved fuel efficiency at moderate to high speeds. Catamarans are ideal for passenger ferries, tourist boats, coastal patrol vessels, and high-speed commercial craft because to their wide beam and ample deck space. In recreational boating, sailing catamarans provide solid platforms with great speed potential due to their minimal displacement. However, their width can limit docking options, and in extremely heavy seas, the hull spacing may create slamming forces between the waves and the connecting platform. Trimaran. A trimaran hull operates on identical principles, but has three hulls, one central main hull flanked by two smaller outrigger hulls. The center hull normally bears the majority of the weight and is optimized for efficiency and hydrodynamic speed, whereas the outriggers provide the lateral stability that monohulls lack. Trimarans are utilized in high-performance sailing, offshore racing, naval missions, and increasingly passenger ferries because their design combines the speed benefits of a slender main hull with the stability of multi-hull geometry. The layout provides for even more stability than catamarans while keeping drag to a minimum, resulting in extraordinarily high speeds and smooth handling in open water. One of the main engineering issues is the structural demands placed on the crossbeams that anchor the outriggers, which must withstand substantial dynamic loads, and like catamarans, the wide beam can complicate harbor accommodation. Hydrofoil. The hydrofoil hull is a unique high-speed configuration in which the vessel uses submerged wing-like foils to raise the hull out of the water as speed increases. When stationary or moving slowly, the hull behaves like a typical displacement vessel, but as the foils generate lift, the main body rises above the water's surface, substantially lowering drag and allowing speeds much exceeding what similarly sized displacement vessels could reach. This makes hydrofoils ideal for fast commuter ferries, military patrol boats, and some leisure or experimental watercraft. Their efficiency, smooth ride, and high-speed capabilities are significant advantages, but hydrofoils are mechanically complex and susceptible to debris, shallow water, and adverse sea conditions, as the foils must be properly formed and unobstructed in order to function safely. Hovercraft. A hovercraft or air cushion hull operates by creating a pressurized cushion of air beneath the craft using lift fans. A flexible skirt traps the air and lifts the hull clear of the surface. Because the craft essentially floats on a cushion of air, friction with the water is almost eliminated, allowing for high speeds and enabling travel over water, mudflats, sand, ice, and marshland, terrain inaccessible to conventional hulls. Hovercraft are widely used for amphibious military vehicles, rescue craft in tidal or shallow regions, and specialized commercial or passenger operations in environments where conventional boats would be limited. Their drawbacks include high noise, complicated skirt maintenance, and reduced efficiency in strong winds or when heavily loaded, but their unmatched amphibious capability makes them indispensable in certain roles. Swath. Swath or small waterplane area twin hull vessels use two deeply submerged buoyant hulls connected to the deck by narrow struts, drastically reducing the area of the vessel that interacts with the water's surface. This configuration is designed to reduce wave-induced motion, giving swath ships remarkable stability even in rough seas. Because the majority of the buoyant volume stays below the active wave zone, these vessels experience less pitching, rolling, and heaving, making them ideal for scientific research ships, oceanographic survey vessels, offshore supply craft, pilot boats, and stable working platforms where accuracy or comfort is essential. Their trade-offs include higher construction and maintenance costs due to the complex underwater structure, slower speeds compared to lighter multihulls, and a deeper draft that limits their operation in shallow waters. Pontoon. Pontoon hulls consist of two or more long rectangular or cylindrical buoyant tube structures supporting a large flat deck. They are designed primarily for carrying heavy loads with maximum stability in calm to moderate water. Their design allows for large deck areas and excellent static stability, making them suitable for transporting bulk goods, serving as work platforms, hosting floating bridges, supporting construction equipment, or providing stable bases for houseboats and recreational craft. Their main disadvantage is poor hydrodynamic performance. The flat bottoms generate high drag and are unsuitable for high-speed operations or rough seas.